Hi, we have just seen question 3 and the solution to part A. Let's move on to part B. Part B provides us a screenshot from an oscilloscope and requires us to do the following. Number 1 is to determine or calculate the frequency of the supply. Number 2 is to write the sinusoidal expression for the voltage and current, taking the current as the reference phasor. And finally, to write the phasors for the current and the voltage, and then hence determine the impedance of the circuit. Right, so how shall we start this part B? So let's look at what's required. Now, in order to do that, the first thing we need to do is to refer to the oscilloscope screenshot and to determine where is the cycle, one cycle. So if I were to look at this waveform, let's say I look at the current waveform, it starts here, at this point, reach the maximum here, comes down to cross over to 0 here, and then goes back until it comes here. In other words, one cycle of this waveform is actually 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 divisions. Alright, and 10 divisions is given by 10 milliseconds. Now this means that the time or the period to complete one cycle is 10 milliseconds. So if I want to know the frequency, I can calculate frequency is equal to 1 upon t, which is 1 upon 10 milliseconds. That gives me 0.1 times 10 to the power of 3, which is 100 Hertz. Okay, that's the answer for part 1. Now, part 2, since I know the frequency, I want to write the sinusoidal expression. So how do I do that? First of all, I calculate the angular velocity, which is 2 pi f. That gives me 2 pi times 100, and that's equals to 200 pi, or let's do a quick calculation. Pi times 100 goes to 628.32, sorry, 628.32 radian per second. Now with that, I can go on to write the sinusoidal expression for the voltage and the current. Now the typical sinusoidal voltage waveform is given as something like that. I function of t is equal to I peak value sine omega t plus any phase angle that I may have. Right? Now from this diagram, from the oscilloscope screenshot, the current starts at the 0 point and ends here. In other words, there is no phase shift for the current waveform. So I can go on to write the value. Before that, I need to determine I peak. What is I peak? Now I peak is the maximum value. In this case, the maximum value is 20 milliamp. So I can write down here 20 milliamp. Okay. So my waveform will be 20 sine omega is 628.32 t. Since the angle phi phase is 0, there's no phase shift, I don't need to write it down, and that is my sinusoidal waveform for current in milliampere. Similarly, the voltage waveform can be written as the V peak given from this chart here is 25 volt. And the important thing now is notice that the voltage waveform and the starts much later, one division later. Now one division later means that one division out of earlier on we said one cycle is 10 divisions. So 10 division multiplied by 360 degrees, that gives me 36 degrees. That means the voltage waveform has a phase shift backward of 36 degrees. So I can then proceed on to write the waveform as 25 sine 628.32t minus, right, in this case because it's lag behind, minus 36 degrees volt. That is my sinusoidal waveform for the voltage. Okay. Now, if I were to just, now what we do is, in order to go on to do the next part, I want to convert each one of these into the phasor equivalent. For example, IT, I can write I is equals to I root mean square with the angle 0. So what is root mean square? Root mean square is the V peak or I peak divided by root 2 angle 0, which is equals to 20 divided by root 2, which is calculation, 20 divided by root 2, 14.14, 14.14 angle 0 milliamp. Remember, this is milliamp. And the voltage phasor V is given as peak voltage 25 divided by root 2, but it has a phase angle of minus 63. So that converts as 25 divided by root 2, 17.678, 17.678 angle minus 36 degree volt. Now if you want to determine the overall impedance of the circuit, impedance, as we know from Ohm's law, is V over I. That gives me 17.678 at the angle of minus 36 degrees divided by 14.14 angle 0 milliamp. So please remember that. So that gives me 17.678 divided by 14.14, it's 1.25 times 10 to the power of 3. Remember this millivolts, so it becomes here ohms. That's 1250. Of course, you can insert the angle in as left angle minus 36. Now this means that the phase angle, the phase relationship between the voltage and the current is 36 degrees. So we have the answer for this, answer for this, answer for this. Alright, that's all for this question. I hope you have learned something from here.